So now, here we're going to look at making a current source with an NPN bipolar junction transistor. A good start for that is a Zener diode right there. Well, the transistor is the start, but the first thing to add is probably a Zener diode. We're going to use a 5.6 volt Zener diode. You got to put it reverse bias to get its Zener voltage. Current has to go through it to get its Zener voltage. So you're going to need at least 2 or 3 volts higher at the supply right there. And I found probably about 6 milliamps of current gets us pretty close to 5.6 volts. It differs just a little bit with different current. But in any case, we will come to the transistor. We have an emitter follower down here, not the whole transistor, and therefore whatever the base voltage is, you lose about 0.6 volts. You can put that across a resistor, so 5 volts will give you about 5 milliamps of current. And then so the collector is going to pass that amount of current, even if you have a load, as long as there's enough supply voltage. So over here we have a pictorial NPN bipolar junction transistor. You can use the 2N3904 for this low current right there. And here's the pin layout. Left pin emitter, middle pin base, and collector. You swivel it. Down here is the emitter with the 1K resistor. We want to set 5 volts across it to get 5 milliamps of current. So at the base there, we got a Zener diode. You got to put it reverse bias and pass current through it to get its Zener voltage right there. So it should be somewhere around 5.6, just changing slightly with a fair amount of current change right there. You know, slightly lower current, there will be a little bit lower voltage than 5.6, and slightly higher, they'll be a little higher than 5.6, but it'll be close to 5.6 regardless. So in any case, collector side, load doesn't matter as long as you got enough supply voltage to power it, plus the rest of the circuitry right there. You could use an LED, no LED, couple LEDs, as long as there's enough supply voltage to power it all. So now we'll actually measure the current with the multimeter. Remember, you got to open the circuit, and the current that we're concerned about is the collector current. It's going to be in milliamps. It's going to be a low level of milliamps. We can set this to milliamps as long as it's less than 600 milliamps. And don't need to move the red probe for anything, but high current, pretty straightforward. It's a nice little auto range emitter, very easy to set. So yeah, we want the current between these 2 points, and it should be about 5 milliamps of current. Doesn't have to be perfect, but there you can see, pretty close to 5 milliamps right there. It's a current source, so if I go directly to the positive supply instead of the cathode of the LED, I'm up at the anode right there. So we're just going around the LED. It's not part of the circuit now. It's the same amount of current. So that is very important for a current source. We're setting the current at the collector regardless of load, as long as there's enough supply voltage. There's 10 volts here. So now we come back to our 5 milliamp current source. It's putting 5 milliamps through the LED. If we had no load, it would still hold, if it was just a short, it'd be 5 milliamps. Or if we had more LEDs, it would be 5 milliamps. And, oops, I don't want milliamp setting. We're going to measure voltage right there. Very important you get it to the right setting. We would blow a fuse when we measure the supply voltage right there. So it's about 10 volts right there. That's we need enough power to set first off the Zener voltage right there, which is about 5.6 approximately right there. You can see it's a little bit higher. That's to be expected. But the base 2 emitter drops about 0.6 approximate right there. That's going across the 1000 ohm resistor right there, setting the current to about 5 milliamps of current regardless of load on the collector side, because we're building up that voltage across the resistor, and the transistor is going to maintain that since it's at the emitter. The collector is going to pass the current needed to maintain it.